Hey Vishal. So we have Praneeth, Ahana, Arush, Vijay, Dheera and Vishal in the class. And some kids are missing. They might join a little bit. Let's get started. So before I start talking about what we are going to do today, a quick summary of what we have done so far. We are in the unit called conic sections, and that is where you guys would have seen me doing all the drama with a cone. We took a cone, we tried slicing it in different possible ways to wrap our head and say that okay fine. If you cut the cone in certain ways, you get this shape. And we started with a cone being cut horizontally with this surface creates a circle. If I am being playful, I cut with a little tilted this thing, horizontal scissor or whatever it is. It gives us ellipse. If I have two cones, two inverted cones joining at the thin edge, and then I cut it with this section, and then you look at what you got. You get two parabolas or inverted parabolas together, and that is what is called hyperbola. So we are going to talk about hyperbola in the class today. So far we have talked about circle, we have talked about ellipse, and we are going to start talking about hyperbola. So, hi Samriddhi. So, in our journey so far, I kind of tried to convince you guys that okay, while circle looks as the base shape to us, we tried bringing a change in our perspective, say okay now, we'll not say circle is a base shape, I will say ellipse is a base shape, and if I squeeze it symmetrically from the two sides, we might end up getting a circle. Hi Sahil.
Hi, sir.
So we are saying that my ellipse is the base shape, okay, where we came across a simple equation for ellipse which says x squared by a squared plus y squared by b squared equal to 1, where a and b are the, I would not say major and minor radius, I'll say a is the radius along the x-axis and b is the radius along the y-axis. This is my equation for the ellipse. Okay, here my ellipse's center is coinciding with the center of the or origin of the coordinate plane. And you guys are able to relate to what I'm saying, right? I'm not rushing. I'm doing it slowly on purpose. Yeah? Dheera, are you able to follow me better so far? Vijay, Ahana, Arush, Vishal, everybody? Everybody? Okay. So here, this is the ellipse where my center of the ellipse is coinciding with the center of the coordinate plane. And this is my equation. Why we are saying this is my parent object? Because if I squeeze this little bit, after I squeeze this ellipse to a point where my major radius and minor radius both became same length as an R, and this also as R, I can replace this by every radius with a R. And we got same base, so we can say x squared plus y squared equal to R squared. So by squeezing an ellipse, we got this one. Now, what I'm doing is, I'm saying, I will still use ellipse as my base shape and I'll play with this. Last time what we did, we squeezed it to make both the radius same, and we were able to relate that with a circle. Now what we are doing is, let's cut it. I took a scissor which is right in the middle of this, cut it and flip it. I had an ellipse, which again, these are the stunts or dirty techniques that I'm using for us to be able to relate to it. I took the ellipse, I cut into two parts and I flipped it. So everything remains the same. What I'm saying is, I'm subtracting something, I'm splitting it and flipping it to the other side. X square by a square minus y square by b square equal to 1. This becomes my equation for the ellipse. And again, we have much more to decode here. Okay, I'm just saying, if you now try relating it with these three shapes, circle, both the radius are the same. X square by r square plus y square by r square x square by r square plus y square by r square equal to 1. That means x square plus y square equal to r square. That gives the equation of the circle. When you have two different radiuses, this is your equation. And again, I'm talking about all the scenarios when my center of the shape is coinciding with the origin of the coordinate plane. When I'm going to hyperbola, I'm splitting it and putting a minus here. And that becomes my equation for the hyperbola. Okay. This is just to relate. There's much more thing that we'll talk about. But is this okay? At least from an equation point of view, you should not have any confusion here. Yeah? Praneet, Dheera, Vishal, everybody okay? So, let's wipe off the history and make a fresh start. So what I'm talking about is, when I have a minus between my x and y stuff, meaning x squared by a squared minus y squared by b squared equal to 1. This is the equation of a hyperbola. Or y squared by b squared minus x squared by a squared equal to 1. This is also another equation of the hyperbola. And what is the difference between these two? I think whether your parents are here. I see a car. I think that's your daddy's car. Daddy wants car. Okay. Alright. Do you see that?
Yeah.
The white one? Okay. Just give me a second, okay? Are you fine? Yeah. Okay. Alright. Okay. So here, this is the equation of the parabola, and this is the of the hyperbola, and this is also the equation of the hyperbola. And what is the difference? How do we relate to it? That is what we will see in next 10, 20, 30, 40, 50 minutes. Okay? I'm not going to make you guys do any problem. We will make sure that when we look at these equations, both are the equations for the hyperbola, we will try to relate to these two equations and what is the difference between this equation, and how do we visualize the hyperbola that comes as part of this learning exercise. Is everybody with me so far? Arush, Vijay, Samriddhi? So, let me do one thing. Let me use a very small font to create some real estate on my board. X square by a square minus y square by b square equal to 1. And my second one is y squared by b square minus x squared by a square equal to 1. There are two scenarios we are talking about. Now, why I did not keep any agenda for today apart from digesting these two formulas is because I wanted to make sure that we get a very clear view of this one. Now, let's look at the visual aspect of it. Okay, I'm trying to draw some hyperbolas here. And sorry if I keep on using the term parabola when I'm trying to explain hyperbola. So, When I'm talking about hyperbola, I can have a hyperbola like these two combinations, or a hyperbola like these two combinations. Or I can talk about the blue pair, or I can talk about the green pair that you are seeing here. Okay. So it's always coming in pair, right? Hyperbola, when we talk about it's either vertically aligned or horizontally aligned. And what we see here is, and again we are talking about the hyperbola which is revolving around the origin of the coordinate plane, okay, which is symmetric around the coordinate plane, symmetric around the origin of the coordinate plane. So we are trying to figure out whether this equation gives me this combination of the hyperbola or this combination of hyperbola. Okay, so let's look at this. Are you guys with me so far? Here, and these two dotted lines that I have drawn here, that is more like a defining the boundary of the hyperbola. Meaning, here we will talk about that. Okay, I'm not going into those intricate details right now to get you guys confused in the beginning itself. I'm saying this is defining the boundary, meaning my hyperbola will come very close to line. It will almost give like a feeling that it's touching that, and then moves on. Similarly, both the sides. If it's vertically aligned, it comes very close to touching the line and moves away. And the relationship between these two lines is that they are two lines perpendicular to each other, which define the boundary of my parabola. Sorry, hyperbola. Yeah? So far I'm only talking visual stuff. Okay? So now let's look at it. Let's look at this equation. X squared by a squared minus y squared by b squared equal to 1. So let's find out y squared, what is the value of y here? Okay, that's what we are trying to find out. So we'll see with change of x how much my y is changing. So here x squared by a squared minus 1 will be equal to y squared by b squared. I'm just playing with the equation right now. Or y squared by b squared equals x squared by a squared minus 1, or y squared equals b squared by a squared into x squared minus b squared. So basically I moved this guy to this side and this got multiplied with this term and this term both. So b squared by a squared into x squared minus b squared. Okay. So from this equation what we see is this became y squared equal to b squared by a squared into x squared minus b squared. So far I've not done anything fancy, okay? I just took this equation and I'm trying to digest this equation, okay? What is the relationship between x and y? That's what we are trying to figure out. Where a is my radius along the x-axis, b is my radius along the y-axis, and we'll see, we'll talk about that. For now I'm just treating hyperbola as a two pieces cut, the ellipse cut into two equal parts, and these are the two equations. And we are trying to figure out what is the relationship between the minor and major radius, or the radius along the x-axis and the radius along the y-axis. So far everybody is okay, right? I am hoping that I'm not rushing through it. So I just took this equation and I'm just trying to isolate y and find out what is the relationship between y and x here. So y square equals this. So y will be equal to square root of b squared by a squared times x squared minus b squared. Okay. So this is what we have got here. Now what is that is happening with this equation? That is what we are trying to figure out. Let's imagine the value of x is too big. Meaning when I am moving, see this, if you look at this line which is defining the boundary of this one. So I'm just picking one line where my x value is increasing to an infinite value. X becomes too big, infinity. When that is the case, when my x is too big, almost infinity, right? Because this line is going upward, right? My x is increasing and my correspondingly my y is increasing. Yeah? So I'm trying to find out some, what you call, the limiting condition here. Meaning, when my x changes to an infinite value, because there is no stopping here, okay? If I look at this line. When my x changes to an infinite value, what will happen? When x is infinity, let's say x here in this part, b squared by a squared times x squared minus b squared. When this part, this x becomes infinity, this will become almost irrelevant, right? Infinity into some number minus something, as good as infinity, right? Or no? Look at this equation, okay? I have to find, let's say this is y, or let's say this is my age, y. Now I keep talking about my age always. So y is equal to this, okay? So I'm just trying to get a sense of it. If my x value is infinity, I'm just trying to visualize how this line is behaving, which is creating the boundary for this hyperbola, okay? When my x value changes to a very, very, very big number, infinity, then it will be infinity times a squared by b squared, and I will not even care about it. Infinity times a squared by b squared, obviously, will be infinity only, and infinity minus b squared. This guy is too insignificant to even consider, right? B could be 100, B could be 5 million also, doesn't matter. It is too small in front of infinity, okay? So when you are going to an infinite point, meaning when your x value increases to a very, very, very large number, what you will do is, you will say, you know what, I don't really care about this guy. So for the case when x is too big, you will say, I will just ignore this part. It will be b squared by a squared times x squared, square root of this. I'm just ignoring it for a very large value of x. Or that would be, you will say, all are squares. So the value for y I will get as b over a x plus b over a x. Y equals plus b over a x, plus and minus b over a x. And to be very honest with you guys, I have not done anything magical so far. I'm just trying to look at this equation and figure out what is happening here in this case. Okay? Are you guys okay so far? Vijay, Samriddhi, Deera, Vishal? And again, don't say yes if you're not convinced. Trust me, you have all the reasons and rights to ask me for it. What I'm telling you from a journey point of view, I took this equation and I'm just trying to understand what exactly this equation stands for. I know that, okay, this is representing a hyperbola. So we took this equation and we are trying to find out the relationship between x and y from this equation. And we got to this point. Now, these two lines that I see here, which are perpendicular to each other, that defines the boundary of the hyperbola. Meaning, if it's vertically upward and vertically aligned, that could be one scenario. Horizontally aligned, that could be another scenario. But both are aligning within these two lines, and we'll come to that line also. Okay. So we said, okay, fine. This is how I'm able to relate y with x. from this equation, and for a very large value of x or very small value of x, meaning negative infinity, both the case, what is happening to y? This part will become very insignificant. If x is very large, infinity, positive infinity or negative infinity, square of that will get you infinity only. So for very large or very small value of x, this part of the equation becomes irrelevant. We are just looking at the borderline conditions, I mean extreme ends on both the sides. In that case, this becomes irrelevant, and then your value of y and x are related this way. Y equal to plus and minus b over a times x. So you will say take one value of y equals plus b over a times x, and second value of y equal to minus b over ax. Okay? So far it's only mathematical, nothing intuitive, nothing fancy. You guys are okay so far? And trust me, I'm not trying to get you guys confused by doing all this here. I'm just trying to go step by step. Deera, okay beta? Samriddhi, Sahit, everybody? Vijay? Okay. Now, from this equation, let's do one thing. So, whatever was my equation, I simplified that in terms of x and y here. And for extreme conditions, very large value of x and very large value of y, I have come to this point, and now I'm going to say something magical. I have two values for y, I mean two solutions here, plus and minus b over ax. What happens when, so here b over a, okay, so now let's look at it. So y times a equal to plus and minus b times x. That's what you're seeing here. So ay minus or plus bx equal to 0. Okay? This whole equation has come to this point, and I'm converting that to a simple equation. Okay? Now, when y is 0, what happens? What? Okay. So let me do one thing. Sorry, I made a small mistake here. Okay, I probably jumped 2 steps. So we have come to this point. So far it's okay. So we just tried finding out this relationship from this equation. And this, if I go back, y equal to plus minus b over ax. And let's look at this equation from which you were trying to find out this thing, b square by a square x square minus b square. So we just said, okay, when the x value is extremely large or extremely small, meaning extremely, I mean positive infinity or negative infinity, then this will become irrelevant, and you got this. But your actually hyperbola, if you see, it says whatever you get from this minus b square, something much smaller than that, but that is subtracted. So your hyperbola is never going to touch this line. It will be slightly less than one, slightly less than this. Somewhere it will just come very close to it, and that's it. That's the best you can get. So this value minus something. So this equation is not representing hyperbola because you have ignored this part. This is representing your line that is defining your boundary here. Okay? This equation where you have taken out this part is representing the line which is defining your boundary, which is called the axis of symmetry. Is that the right name, guys, or am I saying something different? Pranit or Arush or Vijay or Dheera, anybody? What are these lines called? Asymptotes. I think that's a better name. These are called asymptotes because in in geometry, when you're talking about asymptotes, you're talking about the extreme ends. What happens for one of the variable being extremely big? So when you're talking about one of the value being very big, x being very big, infinitely big, how would y behave? For extremely big value also, it will just come very close to it, but it will never touch. So we are talking about these two lines being the asymptote, and that is what we get from this. So this was our equation for the hyperbola, and we said, okay, when my x value is very big, what happens to this? We'll just ignore this, and that defines my boundary. Say, okay, fine, this has to be slightly less than that. This is the line which says this is a boundary within which your hyperbola has to reside, but it will never touch this line, and these lines are called the asymptotes. Is it so far okay or not okay? I know I'm trying to talk about a lot of loaded stuff in a very easy way, and that is where I might be going wrong. So summary of what I have told so far is, we are assuming that this is my equation for the hyperbola. We are trying to isolate variable in terms of other variable, and we got this. This is my equation for the hyperbola. And we said, okay, for the extreme value of x, extremely large value of x, we can ignore this, and that gives me the relationship between x and y. And if you look at it carefully, if you read this equation carefully, let me take this one. So we have two values of y equal to plus b over ax and y equal to minus b over ax. Let's first understand these equations. This is the slope intercept form. What is this slope? This is the slope. This is the second slope. And these two slopes are, these two are the slopes of the line. Okay? One is this slope and one is this slope. When you have two lines perpendicular to each other, slope of first line and the slope of second line which are perpendicular to each other, that will be equal to -1. If you guys remember or recall. Slope, when the slope of two lines perpendicular to each other, that is multiplied, that gives you a -1. Is that something familiar to you guys, or? So that is the reason I was going a little slow. So let me take you guys a little bit back. I will come back to this one. I am keeping part of it here intact. A quick recap of what we already know. If I have, this is a linear equation, simple, y equal to mx plus c, slope intercept form. What is this? Slope. What is this? Y-intercept. So if you visualize that in a coordinate plane, if I'm talking about this, let's say I replace m with 2 and c with 1. I'm talking about a line which has a slope of 2. Slope of 2 means rise over run is 2, correct? Meaning for every increase of x equal to 1, my y is increasing by 2. That's what is slope, correct? Am I making it like a baby problem, or am I complicating it? I'm just trying to relate to this equation, okay? This is the equation for, this is a linear equation in the slope intercept form, where this represents the slope and this represents the y-intercept, meaning if this is 1, I'm touching this line is touching the y-axis at point at 1, and this is a slope where rise over run. This is a rise, this is a run. So pick any 2 points and you can find out the rise over run, and that is a slope. Yep. Everybody okay so far? Vijay, trying to believe. Okay, so now what I'm doing is I'm coming back to this equation. Y equal to, let's take the first one, y equal to plus b over ax. Okay, here if I'm looking at y equal to b over ax, and if I try comparing that with y equal to mx plus c, I see that there's no y-intercept, meaning my line that I'm drawing, the asymptote, is going through the origin, and this slope is nothing but b over a. So x squared by a squared minus y squared by b squared, this was the equation that we were looking at. A is my axis along, radius along the x-axis, b is my radius along the y-axis. So here this has a slope of b over a, which is radius along the y-axis divided by radius along the x-axis. So we got this line which is defining the boundary within which this has to stay, and this second line is coming from the minus part of it. So this will have a slope, this guy has a slope of b over a, and this line has a slope of minus b over a. Okay? So if I am multiplying these two slopes, how would I get a minus 1? Praneeth, am I missing something here? If you recall.
No.
Okay. So let's not worry about it. Let's not even say that they are perpendicular for now. I have two lines which defines the boundary of this, minus b over a and plus b over a slope. Okay, one line has a slope of minus b over a, second line has a slope of b over a. That is coming from this equation. So look at the whole thing. We had this equation, we tried to isolate y, and we got y equals square root of b squared by a squared times x squared minus b squared. And we are saying for the extremely large value of x or extremely small value of x, meaning when x is positive infinity or negative infinity, I will ignore this part. And that defines my axis of symmetry or asymptote, whatever you call it. Okay, I'll probably get the right term for this. I'm forgetting the term. But this defines a boundary within which you are. Yes, Praneeth.
For it's supposed to be negative b over a and then a over b, right?
Correct. So I'm not claiming this to be perpendicular to each other. Okay. I'm saying that one line is this one, and the other line has a slope of minus a over b. So when I'm talking about positive infinity or when I'm talking about negative infinity, so they are two extreme ends. I'm not saying that these two lines are perpendicular to each other. Okay? I will check on that one more time. I'm just saying that for positive infinity, this is plus b over a. For negative infinity, it's minus b over a. Okay? When I'm going x in this direction. So this equation represents the line of symmetry within which my hyperbola is going to lie. It might be lying this way, or this way. That we'll figure out in a little bit. So this, by ignoring this part, we know what is the line or what is the boundary within which my hyperbola is lying. Okay. Now let's come to this point. This is what you guys were waiting for so far. So I have y equals square root of b squared by a squared x squared minus b squared. Okay, by isolating this equation. Now what happens? I'm trying to figure out if my hyperbola is going to lie like this or like this. Okay, so two different colors, red or the black. Now come to this equation. when, let's say when y is 0, what will happen? When y is 0, what will happen? B square by a square minus x square b square will be equal to 0. That means b square by a square x square minus b square will be equal to 0, or x square, I'm trying to get the value of x here. Okay, so b square goes to that side and a square gets multiplied with that. So x square into b square will be equal to b square times a square. Let me not do it this way. I'll probably show you guys the real calculation so that it doesn't get confusing. So from this one, b square by a square x square minus b square equal to 0. We said, okay, what happens when y is 0? Okay, when y is 0, the square root will be equal to 0, or same thing will be 0, or b square by a square into x square equal to b square. Let's divide both the sides by b square, so it becomes x square by a square equal to 1. We divide both the sides by b square, or x square equal to a square, or x equal to square root of a square, or x equal to plus and minus a. I have come to a conclusive point, but that will not be conclusive for you guys if I don't narrate the whole story. We took this equation and we are trying to figure out, am I talking about a hyperbola aligned horizontally or aligned vertically? From this we tried to isolate y square or find out value of y in terms of x, and we come to this equation because we moved this guy that side and then multiplied by b square and we got this. Okay, now we said, okay, fine, this is my hyperbola, but this is the equation of the hyperbola, same thing, we just came to this point. Say in case of hyperbola, I mean, I have no limits. What happens when my x value is too large or too small? What happens to y? When x is too large or too small, this will become irrelevant. So that gives me y equals plus and minus b by ax. That's a relationship that we derived from this one. From this equation, say, okay, for the extreme conditions, when x is too large or too small, this is the boundary. But then we see that there is a minus to it, meaning this equation that you are seeing here, that defines your limits for this hyperbola, meaning the boundary, the asymptote, right? Asymptote, that's a term used. You can have a horizontal asymptote, you can have vertical asymptote when you're dealing with curves. So when you are looking at the infinity value for one of the variables, you will call it asymptote. So these are two asymptotes, meaning when x is too big or too small, this is the line. So this is the border. This says you never touch the asymptote. You get very, very, very close to it, but you never touch it. So it gets very big. This line defines that, okay, this is a boundary, and your hyperbola is never touching it. It just gets very close to it. How close? As close as minus b square difference, meaning you'll get very close. When b is also very small, it'll give you a feeling that you have almost touched it, but you have not touched it actually. So these were two lines that define your boundary. Now you're trying to figure out whether it's a vertically aligned one or horizontally aligned one. And this line gives you the slope. One line is with a slope of b over a, and second line the slope with minus b over a, because y equal to mx plus c. Here there is no c, meaning both lines are going through your origin of the coordinate plane. Now these two lines we found, and then we went back to this equation. Okay, what happens when my y value is 0? When y is 0, we got x equal to plus or minus a. So these are the 2 points on the hyperbola. When y is 0, x is plus a or x is minus a. Meaning this distance is a, this distance is minus a. Now by just looking at it, what you're seeing is these are 2 points of the hyperbola which is satisfying this condition for y equal to 0. So this equation, when your x square is positive, x square component is positive, it's horizontally aligned. Is it making sense now? No? Not relatable? Arush? Arush still reserving his opinion. Okay, Vijay? Now we'll do a quick check. Now, so all that drama I did for last, how many minutes? Almost 40 minutes. Was to make you guys believe that when you have a hyperbola, there are a couple of things that you are learning about it. You are talking about two equations, possible equations, x squared by a squared minus y squared by b squared equal to 1, or y squared by b squared minus x squared by a squared equal to 1. And you're trying to find out that, okay, these are two hyperbolas and they are within this boundary, which are called asymptotes. Is my hyperbola vertically aligned or is it horizontally aligned? So when we took this one, from this we found y equal to plus and minus b over ax as the equation when we are talking about asymptotes, meaning when x is too big or too small. So positive infinity or negative infinity. So when we are talking about positive infinity, we are talking about this line or the slope as the asymptote. When you are talking about negative value of x, you're talking about this line, and again your hyperbola will never touch it. It will just get very, very, very close to it, but will not touch it because there is an element which is subtracted, b squared by a squared x squared minus b squared. So this part, even if too big, extremely big, but still this guy, regardless of how irrelevant it is, it will still make a small impact and make sure that even if you're tending to get very close to it, you're not able to touch it. Your hyperbola is getting very close to it, but it never touches. So we just could find out the slope of the asymptotes and then, or the line of symmetry. I'll find out the exact name for it. I'm forgetting it right now. But then, and then you said, okay, fine. Now we know what line is defining the boundary. We are trying to locate where this hyperbola is. So when y is 0, see, in this case, when y is 0, if this is the case, it will touch here. When x is 0, it will touch here. Okay. So here, since this part is getting subtracted, we took a punt at it. Okay. We said, okay, how about when y is 0? Then what is the value of x? If I put x equal to 0, see in this case, when I put x equal to 0, what is happening here? When x is 0, it becomes the square root of minus b square. This is anyway the imaginary situation, right? You can find out the square root of negative value unless you start dealing with a complex number. So that's why when I have negative here, I'm not making x equal to 0. I'm making y equal to 0 and find out what is the corresponding value of x. So for this x we found as a. Meaning when y is 0, it's touching the x-axis. My hyperbola is touching the x-axis. When I'm putting x equal to 0, it's giving me an imaginary solution. So what it means is, when x is 0, it is not touching the y-axis at all. Because my x will be 0 only when I'm on the y-axis, when my hyperbola is touching the y-axis. So this is technically not possible. When x is 0, I'm getting a square root of a negative number that is imaginary. So that doesn't exist. So that's why I'm going to y equal to 0, and from that we found that, okay, my hyperbola is touching at these 2 points. So when this part is positive, you are talking about your hyperbola touching at the x-axis at point minus a comma 0 and a comma 0. Is it making sense so far, Samriddhi? Dira is quiet.
Yes.
Okay, everybody okay? Now let's look at this guy. Okay, and I promise I'll not do much of a loaded calculation here. We will just keep it simple. In this case, y square by b square minus x square by a square equal to 1. So we'll just isolate this one. Y square by b square equal to 1 plus x square by a square, or y square equals b square times 1 plus x square by a square, or y equals the square root of b square into 1 plus x square by a square. Okay. Now in this case, you can make x 0. When you make x 0, this whole thing became 0. So b square into 1. So y equals square root of b square. So that will give you y equals plus and minus b. So y equal to plus, when x is 0, it's touching at b comma 0 and minus b comma 0, 0 comma b and 0 comma minus b. So here in this equation we just got to the same point. How is the relationship here? And we are saying, okay, fine, when my x value is 0, y equals plus and minus b. How about when y is 0? When y is 0, what will happen? Look at this one. When y is 0, what will happen? B square 1 plus x square by a square. Okay. So 0 equals b comes out 1 plus x square by a square. From that, what you found is this b you can take out. So 1 plus x square by a square equal to 0. X square by a square equal to minus 1. X square equal to minus 1 into a square, that is minus a square. X will be equal to square root of minus a square. You are coming to the same position where you have to find out a square root of a negative number, and that is for all practical purposes imaginary. Meaning, when you are looking at this equation, for x equals 0, you are able to find out the value of y. You are seeing that your hyperbola is touching the y-axis at 0 comma b and 0 comma minus b. But when you are saying x equal to y equal to 0, meaning you are trying to find out where it's touching the x-axis, you are only finding an imaginary solution to it. That means this hyperbola will never touch the x-axis. That means this is vertically aligned. This is horizontally aligned. Now, all that we talked about so far, the key takeaway from that is, if your x part of the equation is positive, you are talking about the hyperbola being horizontally aligned or aligned along the x-axis. If your y part of the equation of the hyperbola is positive, you are aligned along the y-axis. Yeah? So, if tomorrow somebody says, for argument's sake, I don't know whether it's the right equation or not, but if somebody says 2x squared by 9 minus 16y squared by 225 equal to 1. In the first glance, you see that, okay, x squared by something, y squared by something, and minus here. So this is certainly not ellipse, it is hyperbola. Is it aligned along the x-axis? So, in the question paper you will have these options, okay? Second option. Third option is let's say here. Fourth option is here. Okay. Just by looking at it, you have to find out which of the diagram is representing this equation. As soon as you see this, your x component is positive. So this is aligned along the x-axis. So this one and this one you'll simply rule out. But I'm not going to look at these options. Now between these two, again, here x square, 2x squared by 9 minus this, okay. Here your x squared by 9 by 2, 9 squared by 2. This is your x squared by, this is your a squared minus 225 by 16. This is your b square. So you know when it is aligned along the x-axis, x is equal to a. So this is my a square. So it will be positive a and negative a. How much is that value? That is, there's some value. There's some value of a. This is certainly not 0. So my hyperbola cannot coincide near the origin of the coordinate plane. So without doing any calculation, you can simply, intuitively you can relate and say, okay, this is my option. I'm not going to care about other 3 options. And trust me, we are going to practice more problems. But today I purposefully wanted to make sure that with my successful or failed attempt, at least I help you guys to visually relate to what is the hyperbola first, how it is derived from a equation of the ellipse, how is the equation for the hyperbola different from the equation of the ellipse, and then depending on the sign of the x or y component of the hyperbola, how do you visualize which way your hyperbola is aligned. That was the agenda I had. That's why I did not put any question here, because if I would have rushed for solving some problems, I would have probably not looked at this aspect of how do you wrap your head around this. Did I make a little bit of sense, or I kind of got everybody confused to the greatest possible extent? Everybody clear? Deera, Arush, Sahit, everybody clear? Comfortable? So let me do some quick checks. Some quick checks. I'm not checking you guys. Okay? I'm checking myself, my skill, my ability to teach you guys. Okay? Because if I'm not explaining things well, it is not your fault to go wrong. You will go wrong only if I'm doing a horrible job as a teacher. So let's see. I'll randomly pick up some names. I have x squared by 5 squared minus y squared by 16 equal to 1. And this is a question for Dheera. So Dheera, can you tell me better, is it horizontally aligned or vertically aligned?
Is it horizontal?
Yes, it is. Simple. My x part is positive, it will be horizontal. Yeah? Alright? Okay. Now, I have another question. Let's say, everybody agreed with Dheera, right? Okay. Now, I have x squared. Let me twist this question. I have y squared by what am I talking about? Praneet, any idea? Again, see, this eventually becomes a parabola for us. If you have this component and this component both, see here I can assume this to be x squared by 0 square. Okay? Right? No. Nope. I cannot assume that way. 0x squared, okay? 0x squared by let's say 49. Net I am saying this part becomes 0. But I still have, so first thing is, let's say this is 0 or positive 0, whatever it is horizontally aligned. But the problem here is, there is no second part. This eventually becomes y squared equal to 59. So y squared minus 59 equal to 0. Sorry. This is leading more towards a parabola. Okay. I don't know if this is a perfect parabola or not. I've not thought about it yet. But so basically it will end up being 2 points. Y, we deleted the whole thing. X part is completely gone. So we'll end up with just 2 points. Okay, when y is plus square root of 59 and y is minus square root of 59. So you deleted the x component completely, so there is no x component, only 2 points. Okay, along the across the x-axis. So but that was just I was trying to see how do you relate to it. Okay, now if I randomly say minus, okay, let me trick you guys a little bit. So again, the example that I am giving you guys, right, it might not be a legitimate example. It is not coming from any books. It's coming based on my whims and fancies. Okay, I'm just cooking it up on the fly and forcing you guys to think about it. Let's say x squared by 72 plus minus y squared by 69 equal to minus 3. Now tell me, what hyperbola we are talking about? Is it horizontally aligned or vertically aligned? What do you think, Arush? Sorry if I'm putting you guys on the spot. I'm just trying to get a sense of how you are thinking about it. X squared by 72 minus y squared by 69 equal to minus 3. What do you think, Arush? Is it vertically aligned, horizontally aligned? Or Sahit maybe? No, you guys are super hungry for dinner. Ahana, tell me better.
Would it be horizontal?
That is one point of view, but I'm not that. Yes, Arush.
Is it vertical?
It is vertical line. So see, you guys are going with my face value. I might look very amiable as a person, but when it comes to math, I'm a little crooked at times. So I did that on purpose. Let's see what Praneeth says.
Vertical.
Vertical, Vishal. Go for it, Vishal. Tell me what you think. You also did vertical. Yeah, so Ahana, to your point, beta, it is vertical, okay, because I was tricking you guys. My equation for the hyperbola is x squared by a squared minus y squared by b squared equal to 1. I have positive 1 on the other side of equal to sign. I put a minus 3 here because I'm trying to misguide you guys by putting a negative here. Ultimately, I have to have only 1 on this side. That means I would end up dividing x squared by 72 by minus 3 and this also by minus 3. So what will happen is, this guy will become x squared by 72 into 3, 216 I think, yeah. Minus 216 because I have a minus here. And this minus into minus will become a plus y squared by 69 to 3, which will be 3 times 9 27, 6 times 3 18 plus 2, okay, 207 equal to 1. And it flipped the whole story. Yeah? Does that make sense? Dheera, Hana, Vijay, Sahit, everybody? So, one thing is for sure, even if I talk about a lot of complicated stuff, you guys have to stay very simple and firm with your understanding of concepts. My equation for ellipse is going to be x squared by a squared plus y squared by b squared equal to 1 when my ellipse's center is coinciding with the origin. My equation for the hyperbola would be this when it is horizontally aligned, and it will be this where it is vertically aligned. But on the right hand side, I am supposed to have only 1 as a positive one. Even if somebody tricks you to check your eyesight and just puts a minus here, that small cute looking sign could change the meaning upside down. So just be vigilant with that, and that would be the trick for the day. Okay? Everybody okay? So with that being said, I'll let you guys go, and we just touch the tip of the iceberg. We'll talk about the foci of the hyperbola, we'll talk about all the things related to it, and then some of the terms that I used vaguely, like the asymptote and the slope of the line. I will get you guys the right term. At least I got you guys a fair understanding of how do you get started with hyperbola, but when we do practice a little bit more, you will see more things coming your way in a more interesting way. So with that being said, I'll let you guys go. Let's meet again next week. Bye bye, good night. Bye bye, good night.
Bye.
Bye bye.